Mm. Hello everyone. Today we are going to discuss about the topic on friction stir additive manufacturing. In friction stir additive manufacturing is the traditional based metal printing through which the metal will be heated by using the frictional mechanism. And after the metal joining process in layer by layer structure, the stirring process has been carried over. So the metal hardening process, softening process, and tempering will be carried out using this additive manufacturing structure. This is the traditional based metal additive manufacturing in existing system. The advanced metal additive manufacturing such as selective laser sintering, selective laser melting are the upgraded version of friction stir additive manufacturing. This is the basic process through which we have discussed with the help of DT based structure. So the first will be empathy. First stage will be the base plate preparation. The second will be material feeding. Third will be stir deposition. Fourth one will be layer building. Fifth will be the finished components. The base plate will be in form of different metal, and the metal feeder will be in different types of metals. So if you are producing the friction by using rotational mechanism through which the metal will get melted and then deposited in the metal plate or the base plate. So after the each base plate, the material will be feeded at every structure with the layer height of 0.5 mm thickness at the every layer. It can be variation up to 1 mm. So through which the layer will be built in the form of zero point 0.5 mm, zero point 0.5 mm of one layer to another. So it will be easily to overcome the uh, uh, post processing and removal structure. So for surface finishing process, post heat treatment and post tempering process will be carried out by using friction stir deposition process. And the process through which the stimulation has been carried out in the slide by using defined stages in DT empathy. So, what will be the process will be overcome is the first layer, it is differentiated on based upon different layers through which we can able to develop a process by using rotational structure, and also the force will be act downwards. So the friction will be generated on layer by layer process, in which the rotating tool will be traveling along the y direction, and the force will be applied towards the negative direction of z axis. And the third will be z axis based upon the layer, how much length and how much layer thickness can be modified by using these type of structure. From the picture, we can able to identify the pin length, pin tip diameter, and pin root diameter. So in order to process the friction stir additive zone, we can able to differentiate based upon the apparatus available in this structure. So this is how the friction stir additive manufacturing deposition process has been carried out by using a stimulation method. From this, we can able to develop as defined stages, which is the second stage in DT. Third will be ideate and prototype. Once the process has been carried out, once the process has been signified, with the help of friction stir additive manufacturing, we can able to develop a most complicated product using a metal material. These type of material can be available in the form of rod, available in the form of plate. So we can able to produce any number of product with any number of structure in a complex geometry by using this friction additive manufacturing. After the each stages from empathy, define, ideate, prototype, and testing. Testing is the main criteria through which the material strength, quality, dimensional accuracy, and the surface finish can be calculated. So in order to find out this process, there are several stages in case of metal based products. The first will be machining for smooth surface finish. The second will be heat treatment. It will be easy to adapt the strength enhancement, and surface tempering and hardening state of work. Third will be the post processing. Once the surface finish is completed, once the machining has been completed, the post processing process has been carried out by using different types of tools. And the last will be calibration. The exact drawing and the dimension has been calculated and then checked with the quality tool available, such as vernier caliper and screw gauge for length and diameter based measurements. When coming to the result, the last part of DT is based on the application and discussion about advantages and disadvantages of friction stir additive manufacturing. The application of the friction stir additive manufacturing is basically on aerospace components, automobile parts, mold and tooling repair, large scale metal structure. So these can able to process large scale metal structure with different complicated design can be feasible by using this friction stir additive manufacturing. Then the advantages will be no melting of material. Metal melting stages has not been carried out here. Then the second will be superior mechanical property. Compared to the traditional manufacturing, friction additive manufacturing based product have a superior mechanical property. And the third is the main thing, minimal material wastage. Then coming to the disadvantages, limited material variety. Varieties of materials are very limited. The second will be complex tool wear. Third will be slower build rate. We can able to produce a large amount of product within 2 to 3 days. It will take around 2 days to complete the customized complicated structure with a high volume. So this is the main drawback of friction stir additive manufacturing. This is about the basic metal additive manufacturing process through which the friction plays the key role in friction stir additive manufacturing. Thank you.